Hey folks, so in this lecture we'll start talking about lists, which is a data structure, okay, which is a data structure. We'll also talk about what a data structure is and why do we need data structures. But for people who have come to Python from a different language such as C++ or Java, okay, it might help you to understand that lists are actually very similar to array lists in Java, okay, array list in Java or a vector in C++, okay. So lists are similar in these aspects, okay. But anyways, we'll start talking about lists, and we'll start with the why, okay. Why do we need lists, or why do we need data structures in general, okay? So let's start with this problem, okay. We have to write a Python program that prompts the user to enter the names of 5 students, okay. But then it displays them in the reverse of the order in which they were given, right? So so the naive working version would look like this, okay. We'll have 5 variables: name 1, name 2, name 3, name 4, and name 5, right? And then each of these names will store a name, right? And that name would be entered by the user, okay. So the first, let's say, the user enters uh, Alice, Bob, Charles, Diane, and Elsa, okay. Okay, so the variable name 1 would contain Alice, name 2 would contain Bob, name 3 would contain Charles, name 4 Diane, right? Name 5 Elsa. So in a way we are uh, we are sort of remembering these names, right? We're remembering these 5 names, okay. Now, how do we print them in the reverse order? All we do is we say print name 5, name 4, name 3, name 2, and name 1, right? So when they were entered by the user, the order was name 1, 2, 3, 4, 5, right? And when we print it, we just reverse this order, right? We start from the bottom up, right? So we say name 5, 4, 3, 2, 1, right? Now, some of you guys might already see the problem with this approach, okay? And the biggest problem with this approach is something called scalability. Scalability, which means it does not scale up. What do I mean by scaling up? So in this program, okay, we asked the user for the names of 5 students, right? And in terms of computer programming, 5 is a very small number. What if you want to do more number of students? Like, what if you want to do 1,000 students, right? Or 1,000,000 students? What then, right? If you want to do that, if you want to write a program or modify this program such that it takes the names of 1,000,000 students, right, or 1,000 students, and then prints them in the exact reverse order, you'd end up having thousands, right? Let's take 1,000, okay? Let's keep it simple. So you'll end up having thousands of variables, right? You end up having 1,000 variables. So it'll look like name 1, right? Name 2, name 100, and keep going, right? Name 100, keep going and keep going, and then name 1,000, right? So you'll have all these variables, okay? You'll have all these variables, and then for each of these variables, you have input, right? Input, enter name, right? So that's the problem with this relatively naive approach, right? Now we know that if we have a large number of things that we have to repeat again and again, we use a for loop, right? We would use a for loop. That's what we have learned so far, right? For loop, or even a while loop, right? A loop in general, right? That's what we would use. Now, if we want to enter the names of 1,000 students, right, instead of 5, we would do something like instead of printing these steps again and again, right, what we would do is we would write a for loop, right? We would write a for loop, okay, and it would look like this. It would say for I in range 1000, okay, which means 0 to 999. So this entire thing would be executed 1,000 times, right? Okay, so for I in range 1000, name equals input enter name. So that's you prompting the user to enter a name, right? And then you save the name in a variable which you have called name. That's it, right? Now the problem with this approach is the variable name can only store the last name entered, right? So it will forget all the first 999 names, okay? That would be forgotten. Okay, the first 999 names would be forgotten, okay, and all it would remember is the last name, because essentially what's happening here is you have a variable called name, okay, you have a variable called name, and you keep overwriting this variable inside a loop. So the first name is Alice, right? Okay, that's fine, Alice. And then you go back to the loop, right? You go back here, right? And what you do is you come back to this statement in a loop, and then you enter a different name. You enter a different name, right? So now it becomes so now you change this to, let's say, Bob, right? Right? And then you go back again, okay, and then come here inside the loop again, right? And then you rewrite this variable, right? You rewrite this variable to Charles, right? So you keep doing this. Essentially, you're rewriting the same location in memory, right? You're rewriting the same variable again and again. So by the time you're out of this loop, this variable will only remember the last name, right? All the others would be lost, forgotten, right? Now, what we need is a data structure, okay? It's something called a data structure to store all the names, okay? So a data structure is a collection of data, okay? It's a collection of data. So a structure that collects data, okay? So data structure is a structure that stores a collection of data. Unlike variables that store like single points of data, right? A data structure would store a collection of data, and it would also let you perform operations efficiently, okay? Now there are different data structures. In fact, there is an entire course that you will go through to learn the different types of data structures and so on and so forth, right? And the different data structures are designed for different operations, okay? So depending on the operations that you perform, the data structures would be different, right? But anyways, that's, again, as I said, it is part of a different course, okay? But a data structure essentially is a collection of data, a structure rather. A data structure is a structure that stores a collection of data, not just one data point, not just one datum, but a collection, right? A collection of data, right? And it lets you perform operations on these collections efficiently, okay? So the data structure that we'll talk about today is called a list, okay? It's called a list. It's one of the fundamental data structures in Python, and indeed you'll find things like a list in any programming language, okay? So you'll find lists or list type things in Java, C++, C Sharp, right? Or any programming language that you might have encountered, okay? So what is a list? A list is a type of a data structure that can hold multiple values under one common name. This is important, okay? It can hold multiple values, but under a common name, right? So in the previous example, we had these multiple values, right? Name, which were stored in the variables name1, right? Name1, name2, name3, okay? So on and so forth, right? And if you look carefully, you'll see that this part, right? This name, this part is common, right? all that's changing between the variables is the 1, 2, 3. Okay, so what if, conceptually speaking, of course, okay, what if we have a data structure that can take this part out? Okay, so can we have something like a name that holds all these data together? Okay, so instead of a uh, of variables which look like this, right? Name1, that's one variable, right? And that's the data inside it. Let's say it's Alice. And then we have name2, okay? And inside that variable, we have a data like Bob, right? And we have name3. And inside this, we have data such as Charles, right? And so on. Instead of this, can we have something like this? Can we have something like name, right? Which instead of these separate boxes, okay, we have something like this, okay? And here we have the individual names: Alice, Bob, Charles, okay? Can we have something like this? So a list is essentially this, okay? This is essentially a list, okay? It stores all these values under a common name, okay? So a list can be thought of as a collection of elements where each element is assigned a unique number. Each element is assigned a unique number known as the index position, or simply an index, okay? So going back to our example here, okay? There are 3 elements, right, to this list: Alice, Bob, and Charles. Each of these would be assigned a unique number, okay? And the unique number will start with 0. So Alice would be assigned a unique number 0. Bob would be assigned a unique number 1. Charles would be assigned the number 2. Okay. So when we want to, so previously what happened was, when we want to access the uh, name stored in the variable name1, all we did was we said print name1, right? We said print name1. Okay. And when we wanted to print the name stored, the variable or name stored in variable 2, name2, we just printed name2, right? Now, with this approach, each of these variables have been assigned a unique value. Okay, so what we can do now is, instead of name1, we can say name, or we can conceptually think of it as being 3 variables, right? Name0, name1, name2. Okay, so that's a list. Okay, so a list can be thought of as a collection of objects where each element is assigned a unique number, which is called an index. We'll see more examples of lists, okay, in the upcoming slides. But for now, just remember this term, okay? Index. Index is the unique ID, okay, assigned to an element of the list. Okay. Now, lists are mutable, which means they can be changed. Mutable means they can be changed, right? So the values of their elements can be changed, okay? And you can add elements to the list, or you can remove elements from the list, okay? So lists are changeable or mutable. Also, lists can be one-dimensional or multi-dimensional, okay? And by multi, it can be 2D, it can be 3D, okay? So on and so forth. It can have any number of dimensions you want, okay? So people who are from a math background, you will sort of remember something called matrix, right? Remember matrices? You have a matrix in which you have like a table sort of a thing, right? Yeah. So another way of sort of visualizing lists is a table, okay? So you can have a table with rows and columns, right? So you have rows here and you have columns here, right? So you can have 2-dimensional lists. You can also have 3-dimensional lists, okay? You can have 3-dimensional lists as well. Okay. So it's as you have more and more dimensions, it becomes more and more difficult to visualize, but you can have them. Okay, you can have multiple dimensions in your list. But in this lecture, we'll only talk about one-dimensional lists. So conceptually speaking, okay, you can think of a one-dimensional list as a table with one row, a table with just one row. Okay, or you can actually also visualize this as a table with one column. That's okay too, as whatever suits you. Okay, so it can be a table with a single row and multiple columns, or you can visualize this as a single column with multiple rows. Okay, whatever suits you. Okay, but just remember that Python does not, this is just a concept. Okay, or a conceptual visualization. Okay, this is not how it is stored in Python. Okay, but or you cannot assume that this is how it's stored in Python. Okay, so this is just a conceptual visualization. You can just visualize it as either a row, right, or a column. Okay, so that's a list. Intuitive, right? A list is nothing but a collection. That's it. Okay, and we will only talk about one-dimensional lists, right? So how does a list so what are the characteristics of a list, right? So we have, in this figure, we'll have a list which is called grades, right? Now the grades will be a one-dimensional list which will store the grades of 6 students, right? So it will be a one-dimensional list and it will store the grades of 6 students. Okay, so let's assume that the grades are uh, grades are so A, right, A plus, B, C minus, A, B. Okay, so the very first thing that you might notice is you can have duplicates, right? You can have duplicates in the grade. Okay, so these are the values that you have stored inside the list called grades. Okay, now as we have seen before, that each of these values would be assigned a unique index, right? So the index starts from 0. So this would be 0, this would be 1, 2, 3, 4, and 5. These are called indices. Okay, which means it's sort of a positional argument. Okay, so it sort of suggests the position of an element in the list. So this is position 0, position 1, or location. This is location 0, location 1, location 2, 3, 4, and so on and so forth, right? So this entire thing is a list which is named grades. Okay, so you can think of a list as if it were 6 individual variables: grades 0, grades 1, grades 2, so on and so forth, till grades 5. Remember, because we start from 0 and there are 6 elements, right? 6 elements in the list. It would be 0, 1, 2, 3, 4, 5, as opposed to 1, 2, 3, 4, 5, 6. Okay, so the last element, the sixth element, this is the sixth element, or you can also call it an item. Sixth item in the list, right, would be referred to by the variable, conceptually speaking, grades 5. Okay, and just remember this notation. So previously, when we started talking about the problem or the premise of this data structure, right, we had the variables name1, name2, name3, name4, name5. Okay, now when you put these in a list, okay, like so, instead of name 0, name 1, name 2, just add a square bracket. Okay, okay, like so. So think of each of these grades, each of these positions, as a separate variable. Okay, think of each of these as a separate variable. So instead of grades, this would be grades 0, right? Grades 1, this is grades 1, so on and so forth, and this would be grades 5, right? Now, conceptually speaking, you can think of grades in this way, but just to add a little bit, a little more realism to it, the way you access these values is using a square bracket notation, okay? So instead of grade 0, you'll say grades, and then within square brackets, you'd say grade 0, okay? Similarly, instead of grades 5, you'd say grades, and then a square bracket 5, okay? So that's how you sort of visualize a grade, and that these are the components of a list, okay? These are the components of a list. So a list will have a name, in this case it's grades. A list will have a size, okay? A list will have a size. So the size of the list in this case is 6, right? Uh, Now a list will also have the elements or the items inside the list. In this case, it's A plus B, C minus, A and B, right? You can have duplicates on a list, so you have two B's in here, right? Two A's, and that's okay. You can have that, okay? That's perfectly fine. Also, a list will have, each of these elements in the list will be assigned indices, which are unique, okay? The elements in the list can have duplicates, right? But the indices would be unique, okay? And these indices are used to refer to the grades, okay? So the first element would be referred to by its index 0, appended to the grades, okay? So it would be grades and then the index within square brackets, right? The item in the second position would be referred to by, or can be accessed by, the index 1, right? So the way you access this variable is grades and then a square bracket and then the index, which is 1. For the second element, the index is 1, right? So that's how you define, or that's how you visualize a list, okay? And that's how we can use list. So instead of having 6 variables, grade 0, grades 1, grades 2, 3, 4, 5, okay? What we can have is, we can have a single variable grades. That's my single variable, okay? Just this one variable called grades. And then all of the individual elements of the list can be accessed by this dot operator, okay? This dot operator, okay? So when you say grades 0, it means the first element of grades. When you say grades 1, it would mean the second element of grades, okay? And so on, okay? So here's another list that stores the ages of five people, okay? So we can name the list something like ages. Remember, the list will have a name, right? And the list will have a size as well. In this case, it will store 5 elements, right? Ages of 5 elements. So I will create a list of size 5, right? Also, the list will have values, of course. So just fill it up with some values like 49, right? 60, 23, 45, 2, right? These are the ages of the 5 people, okay? Also, the list will have an index, right? So an index, as we know, starts with 0, right? So this would be index 0, index 1, 2, 3, and 4, okay? So these are your indices, okay? These are your values, okay? So if I want to access, or if I want to print the value of the third person, okay? If I want to print the value of, if I want to ask the question what, or I'll just ask how old is the third person, okay? That's the question I want to ask, and the answer is, the third person is this guy right here, right? This is the guy, and the third person is accessed by index 2. So what I would do is I would say print ages, and then within square brackets I'll just say 2. Okay. So instead of 5 people now, if you want to store the ages of 1,000 people, you won't need 1,000 variables, right? All you need is a single variable, ages. Okay. And if I want to print the ages of all 1,000 people from reverse, let's say, you will print ages 999, right? That's your last guy, right? And you say ages 998, right? And so on and so forth until you come to ages 0. Now, some of you might already have caught this thing that the advantage of this having a list is that you can use a loop. You can use a loop, okay? And that's the advantage of using a list, especially when you have a lot of data to store, okay? You have to remember a lot of data, and that's what you would use lists for, okay? So what if we have to store not just the names, but also the ages of 5 people, okay? Or the other way around. What if we have to store not only the ages but also names of 5 people, okay? How can we store the names and ages of 5 people? So previously we have been storing ages, right? We have been storing grades, okay? So how can we store both the names and ages, okay? Now, if you know about two-dimensional lists, okay, you might figure out that you can use a 2D list for this. You can use a 2D list, okay? But it's not required, okay? You can actually have two lists. One of the lists would be called names, okay, which will have a size, and the size is, remember, 5, right? So it'll be a list of size 5. And the other list will be called ages, would be named ages, and it would also have a size of 5, right? It will also have a size of 5. So we have two lists, one list to store only the names, right? And the other list to store only the ages, okay? Now, as you know that these would have, each of these elements would have indices, right? So this would be index 0, 1, 2, 3, 4, okay? And this will have index 0, 1, 2, 3, 4, right? And each of these will have names in there, right? They will have names. So the names are, let's say, Alice, I'll just say Al, Bo, Chuck, let's just say D and L, okay? So these are the names. And the ages are, let's say, the ages are 29, 45, okay, 60, 5, and 50. Why not, right? So this is the list of names, and this is the list of ages, okay? Now you might be thinking, how do we get the name and age of a person, okay? Now the idea here is that if you transpose this, right, if you transpose these two arrays, and if you take any one index, right, let's say the index 2, right, the elements in the index 2, so names 2 would be Chuck, right, and ages 2 would be 60. So you can say that Chuck is 60 years old, right? You can say Al is 29 years old, right? Bo is 45 years old, right? D is 5-year old, right? L is 50 years old, right? So there is a sort of a one-to-one correspondence, right? One-to-one correspondence. One-to-one correspondence. Okay. So if you have to store multiple types of data for these 5 people, right? you would actually have multiple lists for each type, and the way we store the data is the data at index 0 in both these lists, right, in both these lists would correspond to Al, right? The data in the index 1 of both these lists would correspond to this guy, Bo, right? The data in index 4 in both these lists would correspond to L, right? So this is the name, this is the name of the person, this is the age of the person, right? So if you have to use, if you have to store multiple types of data, you can declare two lists, right? Now we have been looking at lists from a purely conceptual point of view, right? But why do we, or rather, how do we actually use lists in Python? So how do we create lists and how do we access the elements of a list, right? So the general form of creating a list, when the elements are known, right? When the elements are already known to you, the general form of creating a list is using this, right? So you have the list name, and then you have an equal to, and then a square bracket, right? Set of square brackets. And inside that square brackets, you'll have the values, right? Separated by commas, okay? Separated by commas. And the space between these commas and the space between these are irrelevant, okay? You can have as many or as little spaces as you want, okay? This is just to improve readability, okay? So these spaces are irrelevant, okay? So essentially what you have is the name of the list, okay? An equal to, obviously this is for assignment. This is called the assignment operator, right? Okay, and then you have a set of square brackets, right? And inside the square brackets you have the items, okay? So the example of a list that contains the ages of 4 people is like this. This is the name of the list, right? This is the name of the list, right? And then you have the equal to sign, square brackets, right? And within the square brackets you have the ages of 4 people, which is 12, 25, 9, 11. So how it looks like, again, remember, is you have this list, ages equal to, and the size of the list is 4, and here we have the ages 12, we have the ages 12, 25, 9, and 11, right? And each of these elements would have a unique index. So the index of the first element would be 0, the second one would be 1, right? 2 and 3. So if I ask you what is the age of the last person, okay, you know that the last person has a unique index 3, right? So you will answer, your answer would be ages 3, right? I would ask you what is the age of the second person. You will say the second person has a unique index 1, so the age of the second person would be ages 1, right? Now, how do we access a value? Just like I said, you use this square bracket operator, right? So we have this array, or I'm sorry, a list called grades, which stores the values B plus, A, and C, right? Now remember, each of these elements will have a unique index, right? So the unique index of B plus would be 0, this would be 1, this would be 2, and this would be 3, right? So grades 1, what will this print? This will print A plus, right? Because that's our index, right? That's the index that we print here, okay? So this will print A plus, okay? You can also use variables or expressions as index. So previously we have been using indices, we have been using constants, right? For indices, we have been using numbers like 3, 1, which are constants, right? But you can also use variables or expressions. So in this example, we have a list which is called gods, right? And it contains 5 elements, right? And the indices are as follows. Zeus is assigned the index 0, Ares is index 1, Hera index 2, Aphrodite 3, Hermes is 4. Okay, that's our indices, right? So because we can use variables and expressions, when we say k equals 3 and print God's k, what happens is this k is replaced by the value which is 3. Okay, and when you say God's k minus 1, again k minus 1 would be replaced by the value of this expression, okay, which is 2, right? So this will print, essentially it will print God's 3 and God's 2, right? And then these God's 2 would be replaced by, God's 3 would be replaced by this guy, Aphrodite, right? Because that's the index 3, right? So it will print Aphrodite and the God's 2 would be replaced by the God at index 2, which is Hera, right? So this would be your output, right? So to summarize, accessing values from a list is really simple. You just say the name of the list, and then within square brackets you specify the index, and each element in the list will have an index 0, 1, 2, 3, right? And the index will tell you which variable to print. Okay, essentially this feels like 4 different variables, right? This is variable grade 0, this is variable grades 1, so on and so forth, right? So it's sort of similar to having 4 variables, but instead of actually having 4 variables, all you have is a single variable, right? And you access the parts of the variable using this index. Okay, now we previously saw an example of how to create lists when the elements are known, but what if when the elements are unknown? Okay, the elements, let's say the user, it's the user's responsibility to give you the elements, right? So in the previous case, what we had was, we already knew that the grades would contain the 4 elements B plus, A, and C minus, or that the fact that this list called gods will contain the elements Zeus, Ares, Hera, and so on and so forth, right? So what I mean is, you already had the elements that you have in the list, right? You already knew the elements. But what if you don't? What if you don't know that, right? In such a case, in such a scenario, what you'll do is you will create an empty list. Okay, you'll create an empty list. Okay, and then for each of the index values, you will assign, for each of the index or positions, you will assign a value. Okay, so the way we create an empty list is using this general form. The name of the list equals to, within square brackets we say none, which is a keyword in Python. It's a Python keyword, right? It's a Python keyword. Okay, and then times n, where n is the size of the list. N is the list size. So essentially this step right here creates, this step creates a new empty list of size n, whatever n is, right? N can be a constant. Okay, n can be a constant, n can be a variable, or n can be an expression. So let's say n is equal to 5, so it will create a new list of size 5, and the list would be empty. So all of these would be empty, all of these cells would be empty. Okay, but it will still have the indices ready. So this would be index 0, index 1, index 2, 3, and 4. It will have the indices, but all the data values inside these indices would be empty. So the next thing we do is, for each of these list elements, we assign a value by their indices. Okay, so you'll say things like, list name. Okay, list name, the name of the list, and then the index equals value. okay, for each of these individual elements, individual indices, right? So you say, let's say you'll say index, I'm sorry, list, you'll say list 0 equals, let's say you want to have positive integers, right? Or a variable, I'm sorry, let's say you want to store the ages. So let's say you say list 0 equals 29. At that point, this one will store 29. The rest would still be empty, okay? And then let's you say you might say list 4 equals 5. So this one will have 5. Then you might say list 3 equals 50. Then this will have 50. Okay? So you first create the empty list, okay? Given the list size, okay? You first create the empty list, and then you can fill up the values one by one. And this is especially useful if you don't know what these values are beforehand, right? So let's say the values are to be entered by the user. So the user will enter the values. What if you have a situation like that, right? So in the previous case, you already knew the values beforehand, so you could directly, or not this one, okay? You could directly create the list because you knew what the values are, right? 12, 25, 9, 11. But in this case, you don't know the values beforehand, okay? Let's say the user is giving you the values. In such a scenario, what you'll do is you'll create an empty list first using this syntax right here, okay? List name equals none times n, where n is the list size, okay? And then you'll take each of the individual indices and store the values, okay? So the example that we just discussed, okay, the example here is that we let the user enter the ages, right? So what we do is, let's say we say that we have a list of 4 people and we need to store the ages of those 4 people, okay? So what we do is we say ages equal none times 4, okay? So what happens here is you create a new list of size 4, you call it ages, right? And you also assign the unique indices, right? You also assign the unique indices to each of these positions or each of these items, which are initially empty, okay? None is a synonym for empty or nothing, okay? Now we don't need this anymore. Now we ask the user to enter the grades. So we say ages 0 equals input enter age, ages 1 equals enter age. So let's say the first time the user enters 50, okay? So I type in 50 and hit the carriage return. So ages 0 would be 50. So the first element, the first item would be 50. Okay, so that's filled up. Next, let's say I say 25. So the second guy is 25 years old, right? So I save that in ages 1. So ages 1 will have 25 now. Okay. Now I say ages 2 is again input enter age, and I say, let's say 80. Okay, 80, and this would be 80, and so on and so forth, right? And so on and so forth. Okay, so that's how you create a list when the elements are unknown, when the elements themselves are unknown. So that's how you create a list, okay? But just note that we still know the number of elements, okay? We still knew that there are 4 people, right? So we still know the number of elements or items. Okay, now you can also do things like this, okay? You can also ask the user to enter the number of items, okay? So you can also say n equals int input, right? And then ask for the number of items, okay? And then you create a new list of this size n, whatever n is, right? So you can say ages equals none times n. Okay, so n can be a constant, right? N can be a variable, okay? N can also be an expression. So you can actually say things like ages equals none times, and then you say int input. You can also do this, right? Because if you remember this from the subprogramming lecture that we had, essentially what will happen is this will be replaced by whatever the value of this function return is, right? Which would be whatever the user enters, right? So if I say enter 100, this will be replaced by 100, right? So that's another way of creating lists. So to summarize, creating lists when the number of elements are known can be done in two ways. The first one is if we know what the elements are, we can create a list like so. We can just say ages equal to, or the list name equals, and then within square brackets we just say what the values are, right? Separated by commas, right? The other way is if the values are not known beforehand, what we can do is we can create an empty list. We can reserve space for an empty list using this none keyword, right? And then for each of these indices, we actually fill the values like so for each of the individual indices in the list, right? For each of the individual elements in the list, we store the values separately, okay? Now, some of you might have noticed that in this piece of code right here, right, there is a lot of repetition, right? So the only thing that changes between these four statements is this thing right here, right? The only thing that changes is this. So you might have sort of figured it out that this thing can be done in a loop, right? Okay, and we already know that the indices can be variables as well, right? The indices can be variables as well. So instead of 0, 1, 2, 3, we can say k equals 0 and then use k plus 1, k plus 1, k plus 2, k plus 3, right? So if k equals 0, this would be evaluated or replaced by 0. This would be 0 plus 1, 0 plus 2, 0 plus 3, which would be essentially 1, 2, and 3, right? And because we can do this, we can change the entire thing and use a loop instead, right? Use a loop instead. So we can say ages equals none times 4, and then for k in range 4, ages k equals int input enter age, right? So essentially what we did was we took the common parts, okay? We took the common parts out, and the only thing that changes here is this index, right? And the index is initially 0, and then it's 1, and then in the next line it's 2, and then in the next line it's 3, right? So the only thing that changes in this statement is the index. So what we did was we used a variable for that index, which is like this, right? We use a variable ages k equals this, and all we do is we vary this k from 0 through 4, not including 4. So 0, 1, 2, 3, right? And that's what we do for k in range 4, which means 0, 1, 2, 3. Ages k equals int input, right? So this would be ages 0 equals int input, and ages 1, and ages 2, and ages 3, right? Simple, right? Now we have looked at creation of lists when number one the elements are known. Elements are known beforehand, which means before creating the list, right? Before creating the list, the elements are known before creating the list. Okay, we've also seen another method of creating the list when the number of elements or number of items is known, right? But not the elements themselves. Okay, and in which case we create an empty list of the correct size, right? And then we fill up all the individual elements separately. The third way of creating a list, which is the most flexible one, is when you don't know the number, right? When we don't know the number of elements either. Okay, so you don't know the elements or the number of elements. Okay, So in this case, what we will do is we will create an entirely empty list. Okay, so this will create a list which is completely empty. So not just empty like this empty. Okay, this is still a list of size 4, right? It's empty, but it has a size 4. Okay, what we would do is we would create a 0 size list. So this is a list of size 0. Okay, so essentially what you're saying here is that list name, whatever this is a list. You're declaring this to be a list. Okay, you're promising Python that okay, this is a list. And then what you do is you use a form like this. You say list name, then a dot or a period, right? And then append, and then the value. Okay, so every time you call this function dot append, okay, as you might have understood by now, this is a function, right? Function called append, right? Some of you might know what this dot notation is, in which case there's nothing to explain, right? The dot notation, dot operator. But for those who don't know what this is, you will learn this later on in the next course, which is CSC 135. Okay, and this is part of something called object-oriented programming. Okay, a list is essentially an object. Okay, and the dot append is a method or a function of that object. So if you don't understand this, don't worry about it. Just sort of memorize this. Okay, that the way you append, or append means adding, right? You add values to an empty list is using this function called append and using the dot operator right here. Okay, so what's an example of this? Okay, and why do we need a program, okay, in which we don't know the number of elements before, right? So in this example, the program asks the user, or rather it continues asking the user to enter the age, and every time the user enters the age, it asks the user whether they want to enter another one, yes or no. Okay, if the user presses or enters no, then it breaks out of the loop. Okay, so this is a situation where the user doesn't know beforehand, doesn't user doesn't know the number of items beforehand, right? What is an example of this? Let's say you are given a program, you are writing a program to store the names and addresses of all the students in the class, right? Or all the students in the school. Okay, so there are two ways of doing this. Okay, so one is, if you know the number of students in the school, you say, let's say n equals 1000, right? That's the number of students in the school. So you create a list like so. You say names equals none times 1000, right? That's, you create an empty list. And then you say ages equals none times 1000, right? So you create these two arrays, lists, and then you keep entering the data here, right? But what if you don't know the number of students? I mean, you have maybe a ballpark, but you don't know exactly, right? So what you can do is you can keep adding one by one, and if you do that, you don't have to count it explicitly, right? You don't have to count the number explicitly. If you don't want to count the number explicitly, this is the approach to follow. Okay, what you do is you initially create a list which is of size 0. This is a size 0 list. Okay, so initially you have a list which has nothing in there, which is empty, completely empty. Okay, there's nothing in here, it's completely empty. So the first time what you do is you say ages.append int input age. Okay, and what we have done here is See, you can say ages dot append and then a value, and you must know by now that you can also use a variable or an expression, right? Or an expression instead of a value, right? So that's what we are doing here, okay? So we have an empty list called ages. We have an empty list called ages. It's completely empty. And then we use these sort of a format, okay, to keep on appending the values, okay? So we say append the ages dot append and then the value, right? So we say ages dot append and then whatever the value of this one is, right? Int input enter age. So let's say the user enters the first age, which is 10. Why not? Okay. So now initially ages was an empty list, right? It was a size 0 list. Now though, ages will become a list of size 1, and that will contain 10. The only one item in the list at index 0 will contain, this is index by the way, okay? This is index. Okay, this will contain the element 0. And then we ask the user, do you want to enter another one? And you have two options, yes or no. If I press no, at this point I come out of the code, right? And if I press yes or anything else, I will go back to this one. I'll go back to this while loop, right? Go back to this while loop. And because it's a while true loop, right? I will come to this statement right here. And then I'll again say ages.append int input enter age. Now let's say the user entered the second age, which is I don't know, 20, right? At that point, since I say ages.append, what I'm doing is essentially I'm appending an element to the list. So ages will now have a size, ages will now be a size 2 list, which means it'll have two elements. The first element will still be 10, the second element would be 20, right? And the index of this element would be 1. Okay. Again, you go back and you add another element. Let's say 70. Okay, and you call ages.append, which will append another element in the list called ages, and the value of this element would be 70, and the index of this element would be 3. And this will keep going on and on, right, until the user decides to stop, at which point the length of the ages would be however many times this loop was run, right? Okay. So we have seen how to access the elements of a list and how to create list and so on, right? But we started when we started this discussion, we said that we can also alter the values in a list, right? Which is to say a list is mutable, right? Mutable. So how do you alter the uh, the elements of a list or the items of a list? Simple, okay? All you do is, just like you'd access the element, right, using the index, you alter the value using the index as well, okay? So in this case, in this example, we have a list. The name of the list is reservations, right? The size of the list is 3. The size is 3, right? And the indices are 0, 1, and 2, okay? So the first element at index 0 is Navajo, the second element at index 1 is Cherokee, and the third element at index Sioux is at index 2 is Sioux, sorry. So when you print this array, by the way, you can print the list. You can print the list using this statement, okay? You can just print and then within parentheses pass the name of the list, okay, which is reservations, and Python will display the list in this format, okay? List in this format. Now, when you print this list, it will print obviously Navajo, Cherokee, and Sioux because that's what the list contains, right? Now, let's say you want to alter the second element. You want to alter the second element. Right? Now, the second element is at index 1, right? So the way you alter the second element is you say the name of the list, which is reservations, and then within square brackets 1, and then assign. Remember, this is assignment, right? This is assignment. Assign it the value, whatever the value you want to change, right? So if you go back to our previous discussion on creating lists with unknown elements, but known number of elements, right? That's what we do here, right? That's what we do. We just say assign the value. So we say list name index equals value, right? And that's what we are doing here as well. We say list name, which is the reservations, right? And then index, which is 1, index, this is index, and equal to, and the value, okay? And then when you print reservations now, it will say Navajo, Apache, and Sioux. Okay, so this Cherokee has now changed to an Apache. Okay. Now, one of the things that Python lets you do, and you may not find this in, if you are well versed in some other programming language, you might not find this feature in your uh, language. Okay, but what Python lets you do is use negative indices. Okay, so previously we have seen indices which are 0 or more, right? So the indices of these items would be 0, 1, and 2. But what Python does is it lets you access the elements using a negative index, and the negative index would be -1, -2, -3. Okay, so when you say you can access the first element using reservations 0, okay, that is equal to Navajo, you know that, right? Navajo. But you can also access the same element using reservations -3. That would be the same thing. Okay, you'd be accessing the same element. So what Python does is it lets you use negative indices. So you have a list equals to some list, right? And let's say the list size is, let's say it's 8. Okay, let's say the list size is 8. Okay, so the indices would be -1, -2, -3, -4, -5, -6, -7, -8. Okay, and there would also be 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so you can access the elements using the positive indices, using positive indices, or you can also access the list elements using negative indices. Okay, so an example of this would be this. Okay, so we have a list called grades, and the elements are B plus, A, C minus, A, and D, right? So as we have seen that the indices, the negative indices would start from the last one, right? And it always starts from -1. So this would be index -1, this would be index -2, index -3, -4, index -5, index -6, right? So when you print grades -1, that's our grade at index -1, right? So it outputs D. Okay, and then you say when you print grades -3, that's our grade at index -3, so it will output C minus. Okay, so let's stop here right now, and we'll continue we'll continue our discussion of lists and what are some useful operations that you can do with lists and so on and so forth. Okay, but for now, to summarize, okay, a list is a data structure, right? A data structure, which means it's a collection, which means it's a data structure. Okay, uh, which means it's a collection. It's a collection of data, right? Collection of data. So we have seen that lists can be declared using the square bracket notation, like so, right? An empty list can be declared with a square bracket notation, and you can append elements in the list using the append method, right? Or you can actually reserve elements, or the reserve memory for the list. Okay, when you say list equals none times 1000, what happens here is you reserve your RAM. Okay, you reserve your RAM or memory to store. You reserve memory in your RAM, right, to store 100 elements. I'm sorry, 1000 elements, which are initially empty, but you have reserved the memories to store the data. Okay, and then you can use the square bracket notation to store data in the list. Okay, and you can use the same square bracket notation to access the data or modify the data. Okay, so essentially when you have an array called, let's say, ages uh, an array of ages, okay, which has a size of uh, 1000. Okay, what happens essentially is you have 1000. Essentially it's sort of equivalent to having 1000 variables, ages 0 through ages 999. Okay, so essentially it's like having 1000 variables. Okay, and each of the variables can be modified separately, can be accessed separately. You can do whatever you would normally do with a variable. Okay, you can do all those things with the individual variables. The only advantage, and that's a big advantage, is that the ages, the variables, the individual variables, all have a common name. Okay, common name, which means you can use loops. Okay, because these variables have common names, what you can do is, because these variables have common names, uh, what you can do is you can take these common parts out, right? This part and this part, and so on and so forth. You take these out and put these in a loop. Put in a loop, which reduces code duplication, right? Which reduces code duplication. Okay, and it makes it possible to store large amounts of data, right? Makes it possible to store large amounts of data, and not just to store large amounts of data, but also store and to process, both store and process large amounts of data. Okay, so that's it for today. We will continue our discussion on lists, and we'll talk more about creating sublists. Okay, creating sublists from lists, and we'll talk more about uh, important functions that you can do with the list. Okay, but that's for the next class. So that's it for today, and if you have any questions, send me a mail and we can set up Zoom appointments and whatnot. Okay, and as usual, I'll upload a few practice problems. I'm not sure uh, if I will post a graded assignment or not yet for lists, but I can do one which contains problems for both lists and functions and whatnot. Okay, but for now, I'll maybe post a few practice problems related to lists and try to solve them. Okay, and if you have any questions, send me your mail. Okay, right, bye.